Hello world, welcome back to another tutorial. Today we're going to be talking about texture coordinates and how to send those on to the GPU so that we can use them to apply textures or images to meshes. Now, say we have a quad mesh and we want to put a brick wall on it. Well, we need to understand how to put that brick wall onto that mesh. So over the next couple of episodes, we're going to be, getting closer and closer to applying textures to a mesh. But in this episode, we're going to just talk about texture coordinates and how we can use them to create some pretty cool effects when they're interpolated across the rasterizer. So get excited. If you like this video, go ahead and hit a thumbs up button. And if you want more content like this, hit subscribe. If you have questions that you need to ask me or want to ask me about anything we talk about in any of my episodes or even further on, go ahead and go to my Discord channel. That's in the description, and we'll talk and chat. And yeah, it'll be awesome. So let's go. So if our goal is to apply textures to meshes, we need both an image and a mesh, okay? And we need to have this thing called a texture coordinate that ties the points of our image to our mesh somehow, combining them, okay? And then what we can do with this mesh that has this texture applied to it is we can take it, put it into a game somewhere, translate it, rotate it, and scale it inside of our game while the mesh is still showing the image in the exact same location, okay? They need to go together. So we're gonna use something called texture coordinates. So right now in our game engine, we have used a vertex, a struct of vertex with a position, which is a float 3. Now, the position is in Cartesian coordinates, Cartesian coordinates being origin of 0, 0 at the center of the axis x and y and z. Okay, so the origin is going to be at 0, 0 with Cartesian coordinates. That's what the position. That ends up looking something like this, where we have 4 vertices, and each one is from -1 to +1 in some unit area, okay? But if we want to use texture coordinates and apply those to our vertex, we need to use something called UV coordinates or UV mapping or texture coordinates. UV mapping and texture coordinates is basically the same thing. Texture and UV coordinates are the same thing. They can be used interchangeably. Okay, so if we were to use UV mapping on our mesh, it would look something like this, where the origin is no longer in the center, it's in either the top left or the bottom left of our mesh. Okay, and the bounds goes from 0 to 1. No negatives, anything. Okay, from 0 to 1. That's how the texture coordinate is going to work in UV space. So U is going to be the first, the X value, and V is going to be the Y value. Try to understand that. Let's move on. Let's pretend we want to take this two-dimensional texture with these UV coordinates, right, from 0 to 1 with U, 0 to 1 with V, and apply them to this mesh, this triangle mesh. Well, in order to do so, we need to use the texture coordinates of, well, this. Okay, so the top middle vertice is going to be at UV coordinate 0.5, 0, 0. The U being halfway between the texture and the end of the texture, okay? And the V at 0 because it represents our Y value going downwards because it's in the origin of top left. Okay, and the bottom left vertice is going to be 0, 1 because our U is at 0 and our V is at 1. Okay, and the bottom right is the exact opposite of 0, 0, which means it's 1, 1. Okay, so if we give our mesh a property of texture coordinates with these exact coordinates, we should get an output that looks like this. Basically, cookie cut this image and apply it to our mesh. Okay, so that's how texture coordinates are going to work. How do we do it? Let's jump into some code. Okay, so as of now, we have this simple quad and cube just kind of going back and forth on the screen. Now, how amazing that is. We do not need it for this episode. So what I'm going to do is I'm going to stop this. I'm going to go into our sandbox scene, which is located in scenes down here, and I'm going to eliminate do update. Okay, now inside of our quad class, which is located in GameObjects quad, we will remove the cube. So now we won't have a cube, it won't be going back and forth. So if I run this game, it should only have a quad with the colors associated with it. So I'm going to stop that, and I'm going to jump over into shared.metal in our shader file. So let's start with what I talked about in the description. We need to add a texture coordinate on top of our vertex. So I'm going to go here, I'm going to make it a float 2, and I'm going to call it texture coordinate. And this will be set at attribute 2. Okay? So now we have a way to pass a texture coordinate in, or take in a texture coordinate into our GPU functions, into our metal functions. Now, to pass the texture coordinate on to the fragment shader, we need to have it set on the rasterizer data. So I'm going to also add it onto the rasterizer data. So we'll have a texture coordinate on the rasterizer data. Now, just like the color of our vertex gets interpolated over the rasterizer, so will our texture coordinate. It'll work exactly the same. Since it doesn't have this position tag on it, it will get interpolated. The texture coordinate will get interpolated from 0 to 1. Okay? So when we pass the texture coordinate on, 0 to 1, it will be interpolated. Pretty sweet, pretty sweet. Let's jump into our basic shader and go up to the basic vertex shader. Inside here, we need to just we're sending our position and our color from here onto our fragment shader. We also need to send our new texture coordinates equals vin.texture coordinate. See that? Easy peasy pie. Now our texture coordinate is going on into our fragment shader, and we'll come back to that in just a little bit. So now that we have our GPU all set up, we're sending texture coordinates on, we can go into metal types. In metal types, we're going to need to add a couple things. So just because I know we're going to need it, I'm going to extend float 4 as a sizable, and I'm also going to extend float 2 as a sizable. So I'm going to go up here to the top, and I'm going to go extension float 2, because I know we're going to need them in just a millisecond. All right, so now that we have that done, we'll come back to that in a second. We need to send our vertex through to the GPU with a texture coordinate property. So I'm going to say var texture coordinate here. And this will be a float 2. I'll build that. Everything's should be peachy. Oh, it's not. As you can see, we're missing the argument for texture coordinate in our call, in our add vertex function, which we set up in the refactor last episode. I told you this would come in handy. Good gracious. Now we can, instead of having to go through all of these guys, we can just add texture coordinates to these, and it just isn't mandatory. So in the parameters, I'm going to add a texture coordinate. So texture coordinate as a float 2, and that will equal a float 2 with, let's just do 0. Now that is all fine and dandy. At the end of our vertex, we will now add texture coordinate, and we're going to set that to our texture coordinate that we're passing in. So if I build now, everybody should be happy. The whole program is going to compile. It's just going to default our texture coordinate to 0. Okay? Our quad, though, still doesn't have, in the quad custom mesh, doesn't have any texture coordinates. So I'm not passing any through. So what I need to do is I need to go and add some texture coordinates. Just go ahead and put a comma, texture coordinate, float 2, and we'll put a value in there in just a second. But I also will need to do this right here. So I'm going to add them ahead of time. And now we'll go through each one. So I told you the top left is going to be 0, 0. So top left is going to be 0, 0, which means that our U coordinate for our top right will be 1 over on the x-axis. Okay? And the bottom left is going to be 0 on the U and 1 on the V. See how that works? We have top right again, which will have the same exact texture coordinates, so 1, 0. Bottom left will have 0, 1, because we've already done that one before. And the bottom right is going to be opposite of our origin in the top left, so that one will be 1 and 1. Look at that. Now we're sending texture coordinates through. So what I'm going to do is I'm going to press play and show you that our texture coordinates are going through to the GPU. Apparently, I broke everything. This is good, this broke. So what we did forget to do was update our vertex descriptor. If we go back to our shared metal, we put attribute at 2 set to the texture coordinate. We have not updated our vertex descriptor and our vertex descriptor library to have a texture coordinate. We only have position and color. So what we need to do is we need to go ahead and copy color and add texture coordinate to the vertex descriptor. Now, the format of the attribute at, let's make these 2. The format is going to be now, instead of float 4, it will be float 2. The buffer index will still be 0, but the offset is going to be a little different. Now, instead of having just the position in front of it like the color does, so it's float3.size, we need to add the color and the position. That's where the extension for the float 4 came in handy. So since we have a float 3 and a float 4, we need to just add these two together. So I'm going to go float 3 plus float 4 dot size. And yeah, so now the texture coordinate knows, hey, I'm offset by these two values, and it will know what gets passed through. So if I go ahead and run this now, we shouldn't have that null reference exception. And we're back to our normal value. No, we had this at the very beginning. But if I go down here to the bottom and go into the debug by clicking this camera, we'll have some pretty cool stuff pop up. Okay, so where we're rendering our quad, I'm going to go to draw primitives, and you'll see we have all of these different values. We have our buffer at 0, which is just basically our vertex bytes. We have our scene constants at buffer 1 and our model constants at buffer 2, and et cetera, et cetera. But we can go up to buffer 0, check to see that, look, these are our vertices getting passed through. And look at our texture coordinates right there. Right freaking there. Okay? If we go to vertex attributes, you'll notice that we have in of texture coordinates. And if I scroll over to the right, texture coordinate out is the same exact things. We haven't actually updated them, but we are sending them out to the fragment shader. So that's a really good way to just check to see that your data is aligning correctly. Let's move on. Okay, so we're sending our vertex, our texture coordinates onto the GPU. Let's go have some fun with them. Okay, so I'm gonna go ahead and go into our basic shader and go into the basic fragment shader. All right. For now, I'm just gonna comment out our color because we're gonna play with the color right now. I'm gonna set this float 4 color equal to, well, rd.texture coordinate. So this will be float 4. Let's go ahead and start that. We'll go 0, 0, 0, 1. And we're just gonna make the x value, which is red, equal to rd.texture coordinate.x. And instead of doing it that way, I'm just gonna create a float 2 value up here called text coord, and I'm going to set that equal to rd.text coordinate. That way I don't need to call rd.text coordinate over and over again. And then I will call text coord.texture coordinates. Okay, so when I run this, what is going to happen? Oh man, look at our gradient. As it goes from the left to the right, the value of red increases. It goes from 0 to 1. See that? Wow. Now if I go ahead and take this texture coordinate right here and put y right there, what'll happen? What do you think is going to happen? Well, it's going to do other stuff. Now we have G, R, and G working together to fight for these values. So as you can see, we're already doing some, we've done gradients before, but let's take it up a notch, all right? So what I'm going to do above color, I'm going to go float x equals, let's just set it to 0 right now. I'm going to copy this and create one for every single color. So I'll go X, I'll go Y, and I will go Z. Okay, and so for our color, this will now be X and this will be Y. So right now our X, Y, and our Z are all set to 0, so it's not going to look like anything. It's just going to be a black image. But what we can do is we can say X equals the sign of rd.texture coordinates times, let's say actually let's just do times texture coordinate. Okay, so if I go like that and I press play, rd.texture coord, of course, it's already created the value. I will do the texture coord.x, press play. What do you think is going to happen? Well, the same exact thing is going to happen because sign goes from 0 to 1. maybe. Trig's hard. But what I'll do is I'll open up Grapher and I'll show you what's happening. So let's create a 3D graph. I'm going to go to the default. I'm going to choose it. And we have our 3D graph right here. So I'm going to go z equals the sine of y. This is what we have right now. This is what's happening. So we're going from 0 to 1, which is like right there to right there. And if I zoom in on it, it just makes it a flat. As you see, this is in like -1 land. This is in +1 land as it goes from left to right. Okay, so nothing really impressive is happening. But we can change that simply by multiplying our y, simply by going up to our function and multiplying our y by 10, we get different values. Okay, so now we have this wave function where this value goes into 0, this value goes into 1, then back and forth. Okay, so this is like trig. So if I go back to our game and I go texture coordinate.x times 10, let's see what happens. I'm expecting a bunch of like gaps. See, so now we have all these are in the +1 value, and then it gradients off into 0. Back into +1 value, gradient off into 0. Pretty cool, pretty freaking cool, but it's kind of boring. So what I'm going to do is I'm going to take it up a notch. Okay, let's go back to our shared.metal, go to our scene constants, and at the top I'm going to put float game time. Okay, so this is going to be total game time. So right now in the, where we refactored all of our stuff, we now have game time.total game time. So I can just send that up through our scene constants. Let's go to our metal types, make sure we're sending it up with our scene constant. So I'll go var total game time, and that will be a float, and I'll set it equal to 0 because it will be 0. And then now inside of our scene, so let's go down to our game shiz, go into scenes, go to scene. Where we're updating our scene constants, we can call scene constants dot total game time equals the game time dot total game time. Okay, so now we're sending on through with our scene constants the total game time. All right, let's go back into our shaders and use it. So from our vertex shader, we're taking it in on our scene constants. So I'm gonna close this window over here. Our scene constants now has a game time, but our rasterizer data doesn't. So let's go to shared.metal again. Go to rasterizer data. At the bottom, I'll put float game time or total game time. And now in our basic shaders, we're taking in the total game time, and we can output it to our fragment shader. So I will go rd.total game time equals scene constants dot total game time. Okay, so after playing for a little while, I've come up with a pretty cool little way to do this. So what we'll do is we'll take the texture coordinate.x, we will add the game time, we will wrap this in parentheses, and then we're going to multiply that value by 20. I forgot my order of operations. So when we do this and we press play, we get somewhat of a cool output. You'll see we actually have a moving gradient, okay? So it's going from left to right. Now that's beautiful. Let's do the same thing for our y value, okay? So for our green value, except this time we're gonna do y. And we'll see what happens. We should see some pretty cool stuff. So now we have this value moving up and to the left. If I were to do a negative game time here, we should see it go the opposite direction. See, so now it looks like it's going downwards, and it's probably just a mind effing game. So what I'll do is I'll just make this subtract, and then for z, we gotta play with z. So why don't I just go like this? Let's do sine, and we're gonna do tangent, just because we can, of texture coordinate.x. Let's do plus game time times. Let's do 2, so it's a little bit wider. It won't be as frequencied. Oh, that looks like a broken television set. Let's do times 20. Make sure. Let's do x as well, because we can. And now we should have a pretty sweet, like, I don't know, colorful image going across the screen. So that is a cool way to mess with texture coordinates. We're messing with texture coordinates. We haven't actually applied a texture right now, but as you can see, you don't have to use them to apply textures. So I hope you guys enjoyed that episode. I might play around with this a little more and push a little bit different of code up. But yeah, I hope you enjoyed this. Like, subscribe, do all that jazz. See you next time.